let's discuss applications that involve compound interest. So first, let's talk about a couple formulas that we're going to use in this section. So we're going to use the compound interest formula. We're going to say A is equal to P times 1 plus R over N to the N times T power. So we're basically going to be talking about investing money in an account where P stands for the principal. So this will be the amount of money that we are investing. And then A is going to be the amount of money after interest has accrued. So the R will be our interest rate. N will be the number of times interest is compounded per year. And then T will be our time. So when we're talking about compound interest is interest earned on previously earned interest. So every year I earn interest on my investment, the following year the money in my account is more because it earned interest, and I earn that same interest rate on my new balance. So let's just take a really basic example and then we'll look at something a little bit different. But let's start with this one. Whoops. Okay. So let's just suppose you invest $1,000 in an account that earns 5% interest. So let's take a look at these scenarios. How much money will we have in the account in 10 years if the interest is first compounded annually? So let's start with being annually compounded. So this would imply the number of times, so N, that interest is compounded per year would be 1 if it's compounded annually. So I'm going to use the formula. And so let's think about what we're going to plug in. Okay, so the $1,000 that I'm investing, so that's going to be my P. So my P is $1,000. What else do we need to know? The A is what we're looking for. That's how much money will be in the account after 10 years worth of interest has accrued. So the R is the interest rate. So that's 5%. I'm going to write that as a decimal. So 0.05. And then T is my time in years. So that is 10. Okay, so A is equal to 1,000 times 1 plus 0.05 over we just said N is 1 to the 1 times T is 10. Okay, so we'll have a calculator. I would recommend using the ALEKS calculator just so you get familiar with it. This will be 1 plus 0.05, so that's 1.05 to the 1 times 10, or 10 power. I'm just going to go ahead and pull up this calculator on my computer. I'm going to start with the base. So 1.05, and then we're going to take that to the 10th power. Okay, so that's that number, and then we're going to multiply that by 1,000. Okay, and let's go ahead and just round to the nearest hundredth. So this gives me 1628 0.89. Okay, so in 10 years, I would have $1,628.89. So now let's do the same thing, but we're going to look at interest compounded quarterly. So 4 times a year would be quarterly, so n would be equal to 4. Okay, so we would have A is equal to 1,000 times 1 plus, again, the same rate, 0.05, this time divided by 4 to the 4 times 10 power. Okay, so similarly, when we go to plug this in, I'll pull up the calculator. So a lot of times I'll work within the parentheses first, and I'll be taking it to the 40th power. So I'm going to go ahead and look at, okay, what is 0.05 divided by 4? Okay, and then to that, I'm going to add 1. So that's the base. I'm going to take that number to the 40th power, 4 times 10, and that gives me that number, and then we'll multiply that by 1,000. So that gives me $1,643.62. So 1643.62. Okay, so then if we were to do the same thing, but we were compounded monthly, right, then n would be equal to 12. So let's kind of jump to continuously. So if the interest is compounded continuously, we use a slightly different formula that involves the number e. So this is A equals P times the number e to the RT, where A, P, R, and T still mean the same things that we defined them as earlier. So let's jump to part D, and we're going to use our new formula for compounding continuously. So anytime we see compounding continuously, we'll use this formula to indicate that. So again, our P is still 1,000. We're multiplying by the number E. R in this case is the same as before, which is 0.05, and T again is 10. So we'll be looking at 1,000 times E to the 0.5 power, multiplying the 0.05 times 10. So let me grab that calculator again. And let's see, so we would have E to the 0.5. Let's see, how does this calculator want us to plug that in? Let's put the exponent in first. There we go. E to the 0.5, and that gives us this number, times 1,000. There we go. So 1,648 and 72 cents. So you can see the more times the interest is compounded per year, the higher the amount after the interest accrues is. But another example. All right, so we have, how long will it take for a $3,000 investment to grow to $3,687 at an annual rate of 6.4% compounded quarterly? Okay, so the fact that it says compounded quarterly tells us which formula to use. So we're going to use the formula with the n. And specifically, since we're compounding quarterly, that means we're compounding 4 times a year, so n is 4. So let's see, we know that the rate is given, so R is going to be, I'm going to go ahead and write that as a decimal. Whoops. All right, so 0.064. If I'm investing $3,000, that's my P, And then if I have 3,687 after the interest, so as it's grown, then that's my A. So I'm ready to go ahead and plug in. Okay, so if A is 3,687, then that's equal to my P, which is 3,000. So this is 1 plus my R is 0.064 over N is 4, and then this is to the 4 times T. In this case is what I'm looking for. How long will it take for this to happen? So I'm looking for T. So I chose this one because I think it's a little bit more difficult, when you are solving for when the unknown is in the exponent. So let's practice the algebra that's involved here. Okay, so my object is to figure out what T is. So before I start to do anything, I want to get the exponential piece of this equation by itself. So I'm going to divide both sides of the equation by this number out front, which is 3,000. Okay, so that cancels here. So I have 3,687 over 3,000 is equal to, let's go ahead and just get a nice round number here. So I'm going to plug this in. So that's 0.064 over 4. Oops. 0.064 divided by 4. That is equal to that, plus 1 is equal to that. Okay, I wanted to have the Alex calculator open so you could see how to use it. So that's why I kind of keep flipping back and forth. Okay, so that is, what did we say? 1.016. So 1.016 to the 4 times T. Okay. So again, my goal is to get T by itself. So now in order to bring that T down, I'm going to apply the natural log to both sides. Okay, so we're going to take natural log of both sides of the equation. And then what that will allow me to do is now that'll allow me using properties of logs to bring that exponent down in front. So this is the natural log of this quotient, and I'm going to wait and just use the calculator here at the end. Bring that 4t down, and that's natural log of 1.016. Okay, so now remember the goal is to get t by itself. I want just t. So I'm going to divide both sides of the equation by everything but the t. So 4 natural log of 1.016. Whatever I do to one side, I have to also do to the other side. So t is equal to this big quotient. And so now I just need to be able to communicate that to my calculator. Okay. Okay, so now let's communicate this to the calculator. All right, so I want to, what I have boxed right here. So we've got natural log, so we can use the natural log button. This is 3,687 divided by 3,000. So notice it needs to look exactly like it does here. I'm applying natural log to this quotient, and I'm going to divide that whole thing. So I want to make sure when I hit divide, that whole thing is getting divided by, I have 4 times the natural log of 1.016. Then I'll hit equals, and I get, let's see, let's just go ahead and round to the nearest hundredth. So 3.25. Remember, that's years. So I think sometimes the hardest part can be communicating this expression to the calculator. So that's why I wanted to go ahead and do that piece together.